This is the group project for BMM1223 dynamics. Our group project is about single cylinder crank mechanism. Our group member is me, Sylvester Deria Anak Lawrence, Muhammad Shaubil Hakim bin Razman, and Al Imran Hakim bin Al Hakimi. The crank mechanism is a vital component in mechanical systems, converting rotational motion into linear motion, commonly seen in engines and pumps. Analyzing this mechanism involves understanding the relative motion of its part through velocity and acceleration analysis. The velocity of a point on the crank is determined by its angular velocity and radius, while acceleration involves both tangential and normal components. Equations of motion include Newton's law for translation, rotational dynamics for fixed axis rotation, and combined equations for general plane motion. Conservation of energy crucial for efficiency assessment considers both translation and rotational kinetic energies, potential energy, and the work energy principle, which states that the work done by external forces equals the change in the system mechanical energy. This comprehensive analysis ensures the effective design and operation of crank mechanisms in various applications. So this is the single slider crank mechanism problem, which have the point A, B, C, D, and E, and the motion is moving counterclockwise, and the length from point A to point D is 1 meter, from point D to point E is 0.8 meter. The objectives of our project is to suggest the lengths for bar AB and BC. Next is to sketch a graph illustrating the velocity and acceleration of block C. Then determine the force exerted at B, Fb by using the method of equation of motion. And then lastly, determine the angular velocity for rod BC, omega BC by using the principle of work and energy as block C moves from position E to position D. The methodology of this project is to use relative motion analysis, to use equation of motion analysis, use principle of work and energy analysis, and use conservation of energy analysis.
Assalamualaikum warahmatullahi wabarakatuh. My name is Al Imran Hakim bin Al Hakimi. My ID matrix is MA2208. So today I want to discuss how to calculate the length suggestion. So if it is required that block C to move back and forth in between position D and E as rod AB rotates, suggest the length for bar A, B and C. So here we want to calculate the suitable length for the block C to move back and forward. So the first step is we have to use the velocity equation. So first one, we need to conclude velocity of block C, Vc, equal to velocity of rod B plus velocity of rod B respect to C. So velocity equal to omega times R. So we conclude the number which we get from the diagram. Then after we solve it, there is we need to solve it in I component. If you wonder why we use it in I component, because the block C is moved horizontally, so I component is the suitable one. Then after we conclude, we get the value, then we put back in the equation, then solve the unknown. So negative Vc equal to RAB times omega AB, and so on. Then after we got the the value of R of rod C respect to B, then we can use this formula, then we get the answer, which is 16.7712 meter. Then for number 2, we need to conclude and calculate the velocity and acceleration of block C, and including the kinematic diagram. So I have concluded the kinematic diagram in the slide. So the step to find the velocity is the same step as we use in the length suggestion, which is the velocity formula, which is V velocity of block C equal to velocity of rod B plus velocity of rod B respect to C. Then we use the same formula and we get the answer, which is, and for wonder why I component, as I have explained before, which is the block C is moved horizontally, so I component is the suitable way to use. So we get the velocity, which is 1.963 meter per second. So the next step, we need to find the acceleration of block C. So this step is quite tricky and have many steps. So the first one, if we want to find the acceleration, the first step, which is acceleration block C equal to acceleration plus acceleration rod C respect to B, and then the value we need to conclude in this long equation, which is the angular motion, the length, the data, which is 45 degree, the omega square, and that's it. We need to solve it one by one, equation by equation, and we get the angular motion, which is equal to 3. Then after we solve it and separate it in I component and J component, then we can conclude it together and solve it, and insert the angular motion value, which is 3, inside the last unknown, and we got the answer, which is 9.2298 meter per second square, which is equal to acceleration of block C. Thank you.
Okay, Assalamualaikum. My name is Muhammad Shabil Hakim bin Nur Azman, metric number MA22045. Today I want to discuss about equation of motion. We know that the difference between kinetic and kinematics is kinetic deal with the force and motion only and reveals how force affect motion, and kinematic deals with motion only or how an object moves through space without reference to any associated force. Okay, now let me discuss about the question 3. Okay, if the mass of rod AB, rod BC and block C are MAB and BC respectively, suggest the step-by-step solution to determine the force exerted at BFB by using the method of equation of motion. Include relevant free body diagram, kinematic and kinetic diagram in your solution step. Neglect the friction of block C. So here we can find the free body diagram for rod AB, rod BC, block C. So using this equation of motion of radians AB block C, we can write equation and solve for the unknowns TH and TS in terms of given quantities, and after that the mass MBC can calculate using the known length of AB and BC and the desired distance between position D and E. Okay, so let's we discuss about the equation of motion. So we can have Fx for force X, Ft and Mo. So the equation of Fx is MAGN, for Ft is MAGT, and for motion Mo. So at this equation of motion, we can find out the root AB for force Fy, MAG, and after that we can find the for root PC. So once we find the value of TA, TB and FC, substitute them back into the equation for root AB to solve for FB. Thank you.
For the conservation of energy analysis, here is the free body diagram for the movement of the slider C move from point E to point D. For the position 1 is to find the position for point D. Next is for the position 2 is to find the position for point E. The calculation for conservation of energy analysis is T1 plus V1 equals to T2 plus V2. For the first equation for the tension is 1 over 2 mvg square 1 plus 1 over 2 ig omega square. For the V1, also we to find omega y1, because there is no spring in the motion, we can eliminate the formula. For T2, also the same, we get 1 over 2 mvg square 2 plus 1 over 2 ig omega square. For V2 equals to omega y2, then we can substitute all the answer in this formula. Thank you.
Lastly, the conclusion that what we can collect from this project is the study of the single slider crane mechanism provides a comprehensive understanding of the kinematic and kinetic principle governing dynamic system. By exploring how rigid bodies move and interact under various forces, and we can address the complex and challenge inherent in the system. This knowledge is critical for designing robust, efficient and high performance mechanical systems that operate reliability under the dynamic condition. Thank you.